Hi, Dave. Hi, how are you?
Oh, I'm great, Mustafa. How you doing? Thank you so much for having me on today.
No, pleasure to have you. Pleasure to have someone from US again. Normally, our session is 6 to 7 p.m., but for US folks, we normally do it 9 to 10 p.m. Malaysia time. And it'll be great for people to hear from you on contextual automation, which is a buzzword right now because all AI are failing. Everybody talking about AI tools, XYZ, and they are unable to create something out of it just because context or business modeling, all those pieces are missing. So we will hear all these things from you. And thanks for being here. Thanks for accepting our invite on Let's Talk About Data. So our culture on our podcast is, as I was telling offline, that we are not a traditional podcast. We let our guest introduce themselves, so we don't make mistake, right?
Oh, okay.
So I will open the floor for you,
No,
Dave,
no problem.
to introduce yourself. Tell us about yourself, how you started this journey, data and AI, then come to your day job, and then come to your product. I know you have an amazing product, and then we go into from strategic to technical because my audience is very C level and architect level as well. So we will cover all those pieces. Yeah. So Dave, the floor is all yours. Please kindly introduce yourself for our audience.
Yeah. Well, fantastic. Well, I'm very pleased to be your 94th podcast. Is that what
Yeah.
it is? 94th?
Yeah.
So I know you've had a lot of impressive speakers before me. So I appreciate that I'm in very good company today.
Thank you.
I am Dave Duggal. I am the founder and CEO of Enterprise Web. I live in beautiful upstate New York. Many people know New York City, and I was raised around New York City, but now I live with my wife and family up in the mountains and lakes of upstate New York. My background is in starting, turning around, and growing companies. So I've been with a variety of companies, mostly in the tech sector, and coming from the perspective of delivering transformative value, challenging existing what the market is delivering, looking at market requirements, sort of looking ahead to where the market is going, and trying to deliver advanced solutions to customers. So when I founded Enterprise Web, I this is now goes back to 2009. So imagine
No.
you have to almost take yourself back. To take yourself back. 2009 is before the cloud. Cloud doesn't
Yeah.
take off to 2013.
Yeah.
Uh, 2009 is before Kubernetes. Kubernetes and cloud native doesn't come around till 2016. And then it's before serverless. That's like 2017, 18,
Yeah.
right? Of course, before generative AI and all of these things that we now do today. But believe it or not, in 2009, I was already working on um, graph-based, event-driven, policy-controlled, agent-based automation. And I was working on these ideas because I was seeing the way, even though the cloud doesn't come out to 2013, you could already feel with globalization and the internet and the web that everything was becoming distributed, that the enterprise IT estate was becoming increasingly fragmented. Right, and so I know your career goes back. I'm a little bit older than you,
Yeah.
but you've been around for a while, and you can remember those days, right, where you can actually start feel that things were drifting apart, things were becoming more modular, which was good, but also more disconnected, right? In fact, with the cloud, we got more silos,
Yeah.
right, and microservices we even got more, right? Things became more atomic, more distributed, and my thesis was that as the world becomes distributed and decomposed, you need high level abstractions for composition and management to bring it back together again. In
Mm.
other words, if you just disaggregate and decompose and distribute without a model,
Mm.
what do you have? You have anarchy. You have an explosion of endpoints that need discrete management, right? Everyone is managed on its own. And then, of course, then your next level challenge is how do I interoperate across? How do I automate across? And of course, this is exactly what happened with the cloud, on-prem, off, in the cloud, hybrid, connecting microservices, connecting service endpoints. Even today, most companies are still doing point-to-point integration across their data systems and their operational systems. And that makes them brittle, expensive to maintain, hard to change, all of those things. And so my idea, just think of the word enterprise web. The idea was this abstraction, right? This overlay that was based on ontologies and knowledge. In other words, it had a model of your domain, but not a data model. So one thing I want to sort of unpack with you, and we'll go into more detail later as we get to more technical, is there's a difference between a data model, ERD, and an ontology. And the primary difference is that data models and ERDs are concrete. They're actually modeling the explicit relationships between explicit entities. An ontology is an abstraction that says, oh, these are the higher level concepts, types, and policies across my use cases. They're not tightly coupled to any individual use case. And this way, if I map my use cases to my ontology, I can reason across them. Even if each use case has different tools, uses different terms, right, has different objectives. But if I map to a common model, those common terms become things I can query against. Show me this across all use cases. Show me performance. Show me, show me the state of something. What have you. And of course, nowadays you can imagine that same plane, that knowledge layer of concepts abstracted across use cases, across silos, across clouds, across vendors, is also super useful as a shared memory for agents that can come down over the top. Because one of the reasons that so many people struggle with agentic AI and LLMs as well is they have no common model, no common domain abstraction to impose structured, persisted knowledge, policies, and constraints on those models and agents. So this enterprise web, this knowledge plane, becomes an intermediary that speaks to your sources and targets. Databases, devices, systems, services, AI applications, right? Connecting your enterprise through a common model. And through that, you get global transparency, virtually centralized policy control, and end-to-end automation. And again, this probably all makes more sense today, Mustafa, than it did when I was trying to explain it to people in 2009. It made people's heads just exploded. They were like, "How can they do that?" And also back then, but even in recent history, people like to protect their silos and nobody. But now with AI, there's a imperative to create an exposure layer, a common place where you can run queries, inferences, do reasoning across. And so that's me, my background, sort of, and how I came to enterprise web.
No, awesome. Love to have you because not a lot of people has come from the same background. Actually, you are, I would say, very unique and niche person because you have been doing this agent thing, which we call it now agentic, and you have been doing this graph thing, as you mentioned, like 20 years from now, right? And so I think I have a lot of questions, which a lot of people get confused. And I think you are the right person to ask those questions to get those things cleared, right? So when you talk about ontologies and taxonomies, I'm sure you're also referring taxonomy as well, because taxonomy is a very kind of straightforward
controlled
way of doing it.
vocabularies.
Yeah. So when we talk about this, right, the other day I was going through all data modeling techniques. There are around 37 data modeling techniques in the world, right? We don't do a lot. We start from business, we go into information modeling and then knowledge modeling, where this taxonomy and ontologies come, right? Let me set this use case with you, and let's walk through it, right?
Yep.
We all know that agentic AI is here, and we all know that before agentic AI, there was a generative AI, and all this buzzword started with generative AI, right? Where everybody wanted to use LLMs, and they set the wrong expectation with the LLMs that throw anything into the LLM and it'll work. My say was always that the traditional LLMs are trained on a generic model. But if you are using LLM for banking, you need to have banking ontologies. If you are working for telcos, you need to have your model need to be trained for telco ontologies. People don't understand that. I think we have to uncover this piece as well. So let's start from there as well. What is the importance of this knowledge which you are talking? We will come towards your product where I will ask
Yeah.
product level
Yep.
questions, right? But let's
Yep.
let's let's tell the importance to the audience and architects that when you go into the LLM world, what is the importance of domain level ontologies to train your model? As I gave you the
So,
example of banking, telco, and XYZ. Yeah.
yeah. Right, and I think that setup was really good in the sense that generative AI and agentic AI have been presented as magic black boxes that solve all our problems. And this is not the first time in IT that this kind of thing has been hyped to us before, and it always falls short of expectation, right? And the main thing going to ontologies, I'm going to summarize it in one word: trust. Now, there's more words than that I can use, determinism, right? And but I can also talk about other things like efficiency, even security, performance. So I think let's unpack what the LLM generative AI gives us, because agentic AI assumes generative AI, right? It's
Yeah.
all right. So, and some people still to this day think of an LLM, a large language model from generative AI, which is just an aspect of deep learning, right? So deep learning is the category that generative AI isn't. And these are fully, it's a stochastic computation, but it's all fully probabilistic. It's non-Bayesian. Many of your audience who are technical would understand Bayesian models of AI, ML, RL, but they wouldn't. But this is not that, right? Generative AI is the premise of deep learning is it's a rejection of modeling. It's a rejection of symbolic AI. It's a rejection. It's essentially saying, you know what? Actually, all those things are a waste of time. Give me enough data. Give me unlimited data. Give me unlimited compute, and I can answer any question in the world. And the response is sort of. Right? You could sort of do it because probabilities never become facts, right?
Yeah.
And let's look at the benchmarks that these folks tell us. They tell us it's 90%. Often is the number. Oh, 91%, 92. Oh, this one's 93%. But, first of all, this is all a bit of BS. It's all bogus, right? Because a couple of layers. The tests that the LLMs run, they train the LLM on the test itself. Right, so
Okay.
it's like giving your daughters a copy of the answers to a test, and they don't have to
Yeah.
learn anything. They just have to memorize the answers. They don't have to know why the answer is that. They just have to be able to retrieve the answer, right?
Mhm.
And so they get trained on it. So that's one level. But the other thing too is that's hidden in those numbers is all the studies, even Anthropic research, IBM research, Apple research, Stanford, MIT, Harvard. They've all put out research that says actually this 90% is not really true. The more complex your domain, the more complex, which is your point about finance, super complex, telecom, super complex. Any large enterprise is going to be complex, and is the more complex the domain, the more complex the prompt, the more tasks, like if it's agentic, the numbers plummet, right? So the accuracy
Yeah.
numbers plummet down to like 20, 30%. Now you go, okay, well, gosh, I'm an enterprise. Everything I do is complex, right? And so 20, 30% is not good enough
Yeah.
to be trusted, right? And then you take the fact that, oh, this LLM is a black box. It's not deterministic. So if I put the same inputs in, I might get different outputs,
Yeah. Wow.
right? Right. The determinism is explicit, right?
Yep.
Determinism means for this is a logical model that is explainable and is repeatable under the same inputs. The same inputs will always return the same outputs, right? And that's what drives the modern. Is it perfect? Of course not, because it's as good as the model is. But when something breaks, you can trace it to the model, right? You can actually, because it's explainable, you can follow the paths and you can understand it. But you don't have that luxury with an LLM. There is no debugging an LLM. There's just throwing more and more and more context with it. So I find it's easiest to explain ontologies by contrasting it to what people know now with LLMs. So now setting up all those problems with LLMs, that it's not that they're bad, right? It's not that they're not cool. They are cool. It's not that they don't have a role. It's that their role is actually much more limited and targeted than the hype suggests. Right? The hype suggests that these are the everything box, everything's being replaced, all software is dead, all jobs are replaced, and we'll all be poets, and
Yeah. Yeah.
we'll all be influencers, and that's all that's left. We'll all be sports stars. That's
Yeah.
all that'll be left for humans. And this is just simply not true. So the role of the ontology historically, so even before an LM, is to create bigger models so that you can reason across uh, state spaces or domains, right? So the way to describe an ontology, it's actually in computer science or data science, it's actually a theory of a domain. It's a model, right?
Of a
Humans
domain.
make models.
Yeah. Of a
Yeah.
specific domain. Yeah.
Now that domain is a scope of X, right?
Mm.
So it could be a narrow domain, or it could be a very big domain and a very deep domain. The enterprise is wide and deep, right? So think of it this way: a bank, it has all sorts of operations, right? It has multiple silos, but those silos also have layers, right, that go down, right? And then they also have common governance. They have security concerns. They have the non-functional concerns, right, as well as the functional concerns. And if you want to really understand a bank, you can't just walk into a bank, open the front door, and say, "I understand the bank," right?
No.
So how do I get? If I'm the CEO, if I'm the CTO, if I'm somebody responsible, if I'm a chief architect, right? If I'm a VP of systems, if I'm somebody with cross-domain responsibility, how do I understand what's going on if I don't have common terms under which to understand it, right? Because otherwise, I'm just trying to force reports down into different groups, and they're canning things back to me, but they're not really mapped in any consistent way. And then you have to question the accuracy of each report. And if you have to question the accuracy of each report, then the unit, the final report that brings it together, what's the trustworthiness of that, right? So you want a common model. And I think what's interesting about an ontology is, and there will be differences in implementations, but conceptually, an ontology supports mapping to things below. It's not master data management, right? A lot of people in your audience would understand master data management as creating canonical models, and canonical models force conformance, right? And there's really two things. And first of all, nobody likes that, right? Nobody likes having things imposed on them. It's not just ego. It's as each domain actually uses terms in different ways because they're serving a different need.
Yeah.
And so it's natural in communication and specialization that we might have some contention and overlap. So the idea is, a master data management tries to enforce one language on everyone. And by the time you create that master data management model, it's already dated, right? It takes years to create it. It's already dated. It's already broken. Everybody all the divisions that live under it are already frustrated with it, right? And now they're doing things off Remember, what they're just going to do is going to do it in Excel or otherwise, right? And so now you get this drift because the master data doesn't support their actual business, and so you at some point the drift is just going to happen, and now you're going to have data that's not captured, right? And once again, things are broken. And the point of an ontology is to allow each domain to describe itself and essentially just map itself up, right? So it's almost, you can almost think of it as self-selection, right? You can almost think of the ontology as a service rather than an imposition, right? Rather than being something that's top down and push down, you can say, hey, I'm creating this ontology and I would like all of the domains to participate, and they can, and if they have new concepts, we'll try and accommodate the new concepts. But if they actually just have different terms, we just want to map them to a common term. They can still use their term, right? But we just want to map that up. So when we report and say how many X is the same in all domains, right? And we create a level of, it's not really strictly normalization. You really wouldn't say that. But again, it's just common terms. So the role of an ontology is actually creating shared understanding. So an ontology is a theory of a domain. It's a model. It's an abstraction. It allows flexibly for people speaking in different terms to come to one. Almost think of it as like an intermediary language, not the singular, not the master, but an intermediary that allows people to all come together, map themselves to it, and now you have a shared reference model with common terms for shared understanding. And that is critical to where the enterprise wants to go, because what everybody wants in the 21st century is contextual automation. Context comes from knowledge and data. Automation comes from operations. So it's almost this unifying bridge, right? We need to connect the data, data models up into ontologies, and we got to connect that to systems so that we can actually then make intelligent decisions that are responsive to the needs of users and synchronized with our operations and optimize our transactions, right? So that's what everybody, I mean, that's honestly been the holy grail for a long time, right?
Yeah.
Even before generative AI.
Just to clear this one, just to add this, so we are saying when we end up creating an ontology, it has to be domain level. Like for banking, there'll be a separate ontology model, and for telco it will be separate, or both can have the same.
Well, ontology is just an idea like master data management. So yes, each vertical and each business. So you can have vertical, like a financial industry has one. It's called FIBO, the Financial Industry Business Ontology, right? There are ontologies existing. There's people who make ontologies. Of course, that doesn't mean it's an implementation, right? The banking industry has BIAN, which is a model for doing cloud native banking, right? So and it's very abstracted. It's a more technical ontology. I don't even know if they would call it an ontology, but we implement it that way. But then you would still have to bring it to the customer, the actual specific bank, whether it's Chase or Bank of America, a bank in Kuala Lumpur. Is there Bank of Malaysia? Probably, right?
Yeah.
Okay, right. So Bank of Malaysia. So, but each bank, even though banks are common, they're still going to have two things that are different, right? So an industry ontology is nice to have because you can almost think of that as being a bootstrap, something that jumpstarts your project, right? You say, hey, I don't have to do this all by myself, because historically doing ontologies has been very hard. Now that's something my company addresses, but historically doing an ontology is very tedious. So, because think of it this way, most people are very concrete thinkers, right? It's easy to say, this is my project, these are my explicit entities, this is how they explicitly connect, right? It's easy. It's harder to say, and that's why it's moving into like logic, right? It's harder to say these concepts are all the same. Map these concepts at a higher level, independent of a use case. How do these concepts relate to each other, right? in finance, how to like order to cash. Yes, it can be a workflow, but it's actually a set of concepts related to orders, transactions, payments, right? All those things like that. Take any major process and it can decompose into a set of concepts that have relationships with them. And then you can see instances of those concepts might be unique. So
Yeah.
you can have an industry ontology, and industry ontologies help you create one for your specific organization.
Mhm.
As with any standard, most people don't just take a standard off the shelf and implement it 100%
Yeah,
as is.
there's always customization. So that is what I wanted to bring to my audience, which are normally corporate audience, that you can use tools like ChatGPT or Gemini XYZ, but when you bring this LLM world in your organization, you cannot bring a generic LLM world into your organization. You have to bring your domain or industry as per your industry. Then you start using it. That is what I wanted to put it over here. But let's go to the next level, right? Maybe if you differ, I
Yeah,
want.
let me just make one quick point there is I think you're exactly right. Even with LLMs now, people understand that they need to train their own LLM,
Hmm.
right? And so you have companies spending millions, right? I mean, so tens of millions, and they're struggling. Most companies struggle with that. It's very hard. I mean, they're getting better at it, but still. But remember, no matter how much you train an LLM, remember the distinction between so an LLM is deep learning.
Hmm.
It's unlabeled data, right? Unlabeled, unstructured data with unsupervised learning, right?
Hmm.
That's what LLM is. On the other side, you have symbolic AI, which is the original AI, right? It goes back to the 50s.
Yes,
The
yes.
19, right? So, so symbolic AI is and ontologies are part of symbolic AI, and both. The reality is, LLMs need to be trained, but they always remain probabilistic in nature. It's called
Yeah.
stochastic computation. So as much training as you put into it, you can never eliminate the possibility of hallucination.
Yes.
It will never be it. There is no point in which a probability becomes a deterministic thing ever, right? It's like you can split your percentages, you can
It
get,
will
but it
never,
never comes
never.
right. Never, right? So whereas determinism starts with the ideas of rigorous knowledge and facts, right? And so it's deterministic. And so you just like the LM, you would want to train an ontology or invest in modeling, and this is what it is, to make that ontology specific to your organization and specific to your organization's operations. It's what's your supply chain? What's your CEO's initiatives? What's your provenance? Like often the history of an organization, of a bank or anything else like that, sort of shapes its footprint. Oh, this one is a consumer bank and its values are focused on consumers. This one is a corporate bank and it's always been for the big boys, right? Kind of thing like that, right? And it shapes its culture and everything else like that, right? So you always have to take it and you want the model to reflect your actual your operations. So I'm sorry. So, but so people invest in LMs to try and get them better, but they can never get them to 100%. I would argue that an ontology is really a better asset than an LLM because you could be training LLMs for the rest of your life, but an ontology becomes a model you can continue to invest in that gets better over time. Right, it can be learning and growing, and it's a record of who you are. Whereas the LM doesn't give you that transparency. It doesn't, you're just feeding the black box, right?
Yeah.
And I'm sorry.
No, no, that's perfect. So now let's go just to summarize this one, like ontologies for people, maybe a little bit junior people, is all about relationship between entities, right? So every organization have the
Relationship between concepts.
concept, yeah.
It's Yeah,
It
that's concept.
can be
Entities
entity, the same entity.
entities are at the data model level.
Mm.
So the way to think of it is it's the step beyond a data model,
Yeah, yeah.
right? It's a step beyond it. I mean, you could call it a schema because schema just means model, but it's an ontology is explicitly an abstraction
Yeah.
above, and then it can maps down into entities, and then that
Yeah,
becomes like a knowledge graph.
entity is one of the object under these concepts, which can be anything.
Yes,
So I wanted
exactly.
to say that nodes, one node, what is the relationship within one node and the other node? And when we go to the table level and traditional data modeling, there can be only one relationship. But in nodes, you can have n number of relationship, and that is where we say context come into picture. In ontologies, you can have multiple contexts because Mustafa can be an employee for an employee for a company, and Mustafa can be a insurance holder for the same company. Mustafa can be many things for same company. So that is how
Yes.
we are going in. Now let's go to the next level. We are already 30 minutes on top. Now let's go to the bigger, more little bit more technical side, right?
Okay.
Okay, now when we are talking about AI, right, we all know that we need to give context to the AI before
Yeah.
it can generate some reasonable answers for you or reasonable responses for you. And then that is where, and thanks for having this session because I'm a big fan of ontologies, taxonomies, FCOIM. I am a big fan of that. I believe until unless you don't provide this to the AI, AI will not be able to do it. Now question comes, do we know, because we all know that there is business modeling, there is information modeling, there is knowledge modeling, there is now data modeling, which is sorry, which is logical modeling and then physical modeling, right there knowledge modeling sits, which is taxonomy and ontology we are talking about. My obvious, before we go to your product, my obvious question is, are we saying that first we create ontologies and then we create physical models, logical and physical, or you are saying it can be other way around? What's your take on it?
Well, so there's a lot of people that there's a lot of opinions on this, right? So
Yeah, yeah,
on top, if you're on LinkedIn, like we connected, or
yeah, yeah,
in any of reading all the blogs and everything else like that, you have people with many different opinions, and
yeah,
it's based on who they are. I think where they come from and their experiences. Of course, I'm going to have a slightly different view, but let me start with the straightforward answer. And like one of the best people doing this is this woman, Jessica Talisman, who is a quite well recognized ontologist. And she has this ontology pipeline, so you can look it up. Jessica Talisman, you might even know of her, and ontology pipeline. I'm sure it would come up if you Google it. And she has a very specific methodical way, and I'm going to point that out as sort of a great reference for anybody who's doing classical ontology work. I think her method is rigorous and sound, right? And but there are people who debate, and it's her method. I don't want to say it's bottom up, but it's sort of like you have to start with controlled vocabularies to taxonomies to like, right. And right, there's a sort of a linear progression.
mm,
So to explain this to your audience, if they're not familiar, is first the suggestion is generally that you start up with common terms,
yeah,
right? And then common terms start having common definitions and descriptions. And then common terms with common definitions start having common relationships, right? And this is a way you can methodically build that up to having an abstracted ontology. And that's sort of the standard way to do it. I would point out a couple of things. Most people don't do ontology, right? Very few people, So first of all, like labeled property graphs, things like Neo4j and and Tiger Graph, those don't really do ontologies. They pretend that they do. They claim that they do. They're graph databases. They can model graphs of relationships. But they're not formal ontologies. They try to bolt them on the top. So this is now we're talking about a distinction in graph technology and data science and even computer science, right? So there's different ways that people come at this, and a lot of people like to take things like Neo4j or graph label property graphs because they're conceptually easier to do. Well, they're easier to do because they don't force the kind of rigor that the outcome will not be a rigorous ontology. You just don't get there, right? The reason for that is ontologies require formal logic, right? The point, and so semantic web is the way that most people know that you do ontologies. Now, semantic web it's the 25th anniversary of semantic web, and that goes to Aura Lacilla, who's a friend of mine, Sir Tim Berners-Lee, all these other people. In 2001 is the big semantic web paper. It's the 25th anniversary this month, and the whole point of semantic web was to create a rigorous, almost academic level of axiomatic proofs. Okay, let me unpack that for people.
Yeah.
But all that just means is that while when I say that Neo4j doesn't do ontologies or label property graphs don't do it, I'm not being negative. I'm not attacking them. I'm just being objectively true. So, and the reason for that is because an ontology requires a formalism of logic, so that you can actually have an axiomatic proof, means a verification that when I do an inference, that inference is trustworthy. Remember how the whole distinction that we were talking about between an LLM, generative AI LLMs, and ontologies and determinism? So ontologies gain their trust through rigor, through axiomatic proofs at one level on the ontology level, and that comes from that OWL language, right? You're probably familiar with OWL. And it also comes from something called Shackle, which is a constraint language that applies domain rules. And from those formalisms of those rules, you get something that is more trusted, it's more complex, it's harder to do, it's more tedious, right? But it has more value, right? Just like most everything in your life, from raising children or going to work and getting educated, or the more time you put into something, right? The more like I know you've been doing this now for quite a few years, right? And we were talking offline how your podcasts help you at work, and your work helps you with your podcasts, and with your books. I mean, I don't know if people know all about you, but you're a pretty busy guy. But that it's reinforcing, right? So you're building something, and it's because in your mind, your models are getting stronger, right? And that's the same thing of a value of an ontology. So label property graphs are good for modeling complexity. They have some of the properties you mentioned of supporting complex relationships and things like that, and being able to run queries, and what I would describe as light inferences over an LPG labeled, when I say LPG, that's labeled property graph. So there's a class of products called labeled property graphs, and that would be Tiger Graph, Neo4j, others. And I'm only saying Neo4j because it's so popular that I'm using them, again, not as a negative. And semantic web, again, not as a negative, but because they do something. So think of like SQL databases. What is SQL? It's a language. It's a language, right? A relational relationships based on joins for tables and everything else like that, right? And that gets you data models. And data models support queries and analytics, but not inferences, because relationships aren't a first-class citizens. Now, there are some people that will debate with me and say that there's things called, an ERD is a graph, and I can do object relationship modeling. Yes, sort of. But it's a workaround on top of SQL, because you can't escape that SQL is the underlying language, data structure, and database, and that has consequences. Graph databases have a very specific structure, and they support queries, analytics, but also some inferences, because relationships are first-class citizens. So you get a little bit more, right? And then you go and you want a little bit more than that. You go to semantic web, because semantic web has formal first order logic. It supports the axiomatic proofs. So relationships are trusted at the ontological level. So relationships between concepts, like how do you know that a Persian cat is part of the class cats, right? That's an inference. If I say, this, and this are all part of the same class, and I want to run an inference over that, I want to know that that's factually true, that those relationships. So that requires a certain level of verification and first order logic, which is what semantic web is based on, as well as something called description logics. Now labeled property graph doesn't have either of those. Right? It doesn't have first order logic. It doesn't have descriptive logic. So once again, we go a step higher. We get a bit more, right? So we went from SQL to labeled property graph. Now we go to semantic web, and semantic web has also multiple relationships, but it's multiple relationships. But in semantic web, everything's modeled as binaries. They're called triples. So the more relationships you have, the more triples you have, because every triple models a single relationship.
Yeah.
Right? And so what happens is the more complex your objects, the more complex your compositions, the more complex your domains, the more complex your infrastructure, the more complex your transactions, you're blowing out the number of triples, right? And so the problem, and this is actually a problem for SQL, label property graphs, and semantic web, is that all of them generally require pre-optimized queries.
Yes.
Right? And this is a problem, because remember where we started this conversation was context and the importance of context. Context is real time. You and I are talking in real time, and you bring to the table a lot. You have this out-of-band metadata and knowledge, right? And I have this out-of-band knowledge, metadata and knowledge. And so when we talk, most of the time, we're just understanding each other. I'm not saying every detail. I don't have to share that with you. In fact, I'm sharing a lot more detail today because we're talking to a broader audience, and I want to make sure that everybody comes with us. But you and I could probably talk much faster, because of our mutual experiences, because you have a model of the universe and how other things work. And when you don't understand what I say, you ask a very targeted question to fill in a blank. And then I see, that's what Mustafa wants to know, and I answer him precisely. And it's not like an LLM that has to use so much power, right? It has to go through all this computation. It has to process all this data every time. Just even to ask something, it's hard to do things precisely and in a targeted fashion. So the problem with pre-optimized queries. So pre-optimized queries, the reason that they all need that is it's a performance problem, right? It means the more as you go up from SQL to labeled property graph to semantic web, and you start supporting more and more and more complex relationships, well, then processing those relationships, serializing objects. Now I'm getting technical, but these are things that happen in the real world, right? These are what the engines of these languages, the runtimes, do, right? SQL has a runtime underneath it, right? All these things have an engine that translates those queries into the response. And if processing complex relationships, like we know processing complex joins is very expensive computationally. Right? Pre-optimize the query. Same thing with labeled property graphs. Same thing with graph. So if you pre-optimize your queries, you're not really running in real time. It's not it's not an ad hoc real-time query.
No.
There's other problems too. That a pre-optimized query is actually an artifact, right? Somebody engineers it. It's usually quite technical. It's not easy. It's not just anybody. Now they try to do that now with, of course, LLMs. But of course, even that's not perfect, right? It's a very technical thing to do to pre-optimize a query, because you're doing two things. You're trying to understand the query from a business context, but how to most performantly execute that query. Right. So it can be scalable. And so you're trying to bridge something. But now you create the static artifact. And if the model underneath the database changes, you just broke your query.
Everything gone.
Right. So now, so this means those are some of the problems, and I'm just touching on them. So this is one of the things that when I founded Enterprise Web,
Now,
this is one
hold
of
on.
yeah,
A
yeah, yeah,
pause. Now, I was about to say that let's move to your product. That is
yeah.
where I'm
Okay.
coming because we have come from the strategic business level, try to
Yes.
understand what is business information and knowledge modeling, how it
Yes.
goes to the data modeling. Now I come to your product. That what your product do we know? It's an ontology product. You
Yep.
created your product on top of existing physical models, or your product is all about, hey, let's build from top to bottom, which is again business modeling, information modeling, knowledge modeling, physical. Now tell us about your product, then I will try to dissect it, ask questions.
Okay. Fantastic. All right, great. All right. Well, this is
Awesome.
the fun part then. But and I really actually hope the nice thing about these recordings is that people can listen to it more than once,
Yeah, yeah.
and they can play some things back because you and I are exploring some. This is a very big scope that we're
Yeah,
exploring, uh, uh, and uh, and we're going in and out. We're actually crossing some technical domains, right? There are some
of
people who
course.
just know data and just know SQL. There are some people who only know LPG. There are some people that only know semantic web, right? And they might be experts, but they don't understand the differences,
Yes.
right? And you, as an architect, and you've been a lead architect in multiple places, you have to understand how these technologies interrelate, right? And what's the functional and non-functional concerns that they both support. And so when I founded Enterprise Web, I would if I could have used SQL, I would have used SQL. If I could have used LPG, I would have used LPG. If I could have used semantic web, I would have. I did not start off wanting to build my own graph language, but I had to because my motivation was a little bit different. SQL, of course, is what 90% of databases in the world, right? I mean, I'm not criticizing it, right? So please, we're talking objectively, like
Yeah, yeah, of
architects
course.
and academic, right? So LPG also and semantic web have use cases. All technologies have their use cases, and I'm not knocking them. But let me explain first by saying my motivation was different. I'm a business executive, and I always have been. And when I started Enterprise Web was, hey, I'm getting frustrated because I don't have global visibility,
Mhm.
right? I'm this is my company, or an executive in this company, and I want to be able to look down in the company. I want to see the people, the information, and the capabilities. I want to be able to flexibly compose them for service, for purposes, for my business purposes, based on policies. And then I want it to be executable. I want it to deliver behavior, contextual behavior. So that my goal is something very different than the other people doing graph, because the history of graph has just been queries, analytics, and inferences, where and that could be batch. It can be pre-optimized. If it takes 10 minutes to run, you don't care, right? If it takes all day to run, it's a nightly batch. Who cares? And if you're doing operations, that means I'm doing it within the split second of a transaction, right? I need a graph that can serialize complex objects doing thousands of operations per second to contextualize every interaction in real time on demand,
Hmm.
right? So that was my objective, and I had to work backwards. I had to then say, okay, this being my North Star is that every business in the world would like to have real-time, enterprise grade, meaning secure, scalable, performant, right, efficient, contextual, meaning personalized, optimized, right, synchronized, right, automation. Who wouldn't? Right? Who wouldn't want that, right? You would want every decision made on the perfect information if you could have it, right? And so I read hundreds of academic papers. I mean, that's where I started my stuff. I didn't mention this before. So when I first started, because I had done well in my career, I took 18 months off, and I literally went back to the 1940s, and I started reading Turry, Strachey, Milner, Malone, Shannon, right? Bellman. I just read the greats of computer science, and I was like, why do people? I was really trying to why do people do the things this way? And the reality was, for the most part, it was just convenience. For the
Yeah.
most part, people took shortcuts. For the most part, and actually in the earliest days, there was a rational explanation. In the earliest days of computing, of course, the the storage, and the network weren't fast enough, right? To do what the kind of things we wanted to do. But today they are, right? Today compute, storage, and network are commodities, right? We hardly even think about them, right? They're just in the background. They're just resources we consume as services. Right? We just put an SLA on the top and we just, hey, you better be there, right? That's what we expect infrastructure to be, right?
Yeah.
And so I revisited because the smartest people in the world, honestly, Mustafa, don't take this the wrong way, but I think the smartest people in the world are not living today. They were living in the 40s, 50s, 60s, and 70s because they did it in their head. They did it as theory. They did it as math, right? Now, they couldn't implement their ideas. The infrastructure wasn't ready for them. But they actually, instead of just saying, what could I do that was easy, they said, what would be the right way to do it? Right? And so I studied all these guys and I was like, oh, wow, these guys had fun. We talk about standing on the shoulders of giants, right? Like these guys had great ideas, right? Like amazing, right? And the things that they were doing in theory was super impressive. So you go back to McCarthy and the original AI and metaprogramming. You go to that Bellman is a recursive reasoning. You go to like Strachey and dynamic types, and you get to like things like Bacchus and functional programming, and you have this like all these computer scientists are building on each other over time. It's very exciting when you read it.
Yeah.
Actually, it's almost like a novel, right? And maybe you could write a book on it, and maybe together,
Yeah.
And I would need your help. And so I wanted to solve that problem. So I had to address a fundamental problem first. I had to understand because let's unpack what is context, right? Because that's another word. We've gone through and we've talked about ontologies. We talked about the difference between ontologies and language models. We talked about the differences between SQL, LPG, and semantic web. But what is context? Now, context is not knowledge. It's different. You can have a graph database. A graph database is facts and right? And you can have a semantic web and it's knowledge. If I have a library of books, which I do over here, that's knowledge. And to the extent I've read it, I have some of that knowledge. But it's only context when I use it.
Yes.
Right?
What do you want? Yeah, correct.
Because context is, let's have a definition, you and I, of context, because this is another word that's being abused. Everybody's saying this is context, and I think they're all full of it. Because once again, they're using it for convenience. What they're really talking about is narrow context. Oh, this is a little bit of state and telemetry. That's context. Well, sort of. This is from implicit context from my emails, and okay, that's a little bit of context, but it's not all my context, right? This is my information from my ontology. Yeah, okay, that's part of it too. But if you really think of it, context is the application of knowledge and facts to an interaction. That's what context is.
Yes.
Right? It's like we're having this conversation. This is an interaction, you and I just came up with a new definition in this call to describe context as the application of knowledge and facts in other words, because we want to be understood. Right? We want to actually drive the conversation forward. If somebody doesn't, think of it this way. Another way to say it is when you have a conversation with somebody who doesn't share your knowledge, let's say, I'm being generous, right? Who, is maybe not wide awake yet. I'm being generous, right? That conversation can be very frustrating because you're not in context, right? And somebody that only knows old facts, they're not very interesting, right? Because you're trying to talk in the moment, and when they keep on saying old things, you're like, it doesn't compute, right? And or if somebody has old ideas and not the new ideas, then they sound out of date, right? So context is the relevant knowledge and facts applied. So now relevant means you have to filter
Yes.
What is the so now context means how do I filter that relevant knowledge and facts to apply it to this interaction, right? Now that becomes orchestration, that becomes policy, right? Because RBAC, Mustafa, you might have different permissions than I do, right? RBAC and ABAC, right? This is all right, and I know some of this stuff sounds very esoteric, but all of this is coming up with the agent and agentic right now because people can't govern it, right? Guardrails aren't good enough, right? And so what you really like is context as a service to your LLMs because you would like to enrich your LLMs and you'd like to validate their outputs, right? So you would like the context as a service to an LLM. Let's give you very specific context that's relevant, not 50,000 tokens, not 100,000 tokens. Let's give you 3 tokens. Let's give you 5 tokens because the ontology has the knowledge. I don't need the LLM to be my intelligence layer. I just need it for an inference. And I'm going to just say I have all this great detail in my ontology about my business domain, and I just say, what? Here's some information to do an inference. I'll go back and forth with the LLM 3 to 4 times. That's only 12 to 15 tokens. Super fast, low latency, energy efficient. And the outcome is better because the way we use an ontology, it's not GraphRag. GraphRag sits below the LLM.
Yeah.
And the LLM is still the intelligence layer. It's just trying to help. That's all it is. I mean, if you really think about it, GraphRag is like a document highlighter. Right? All right. That's what it does. Chunk documents. What is that? It's like if you were in college and you had a physical textbook, you highlight it, right?
Yeah.
It's highlighting the parts of the document and giving it to the LM. And you hope and pray the LM makes the right choices, right? And so that's not, and you cannot, with GraphRag, you cannot eliminate hallucination because the LLM is still the intelligence layer. In enterprise web, we're like, that's ridiculous. Why would I ever use an LLM as it's just another form of AI. It's just another thing that gives me inferences, just like AI, ML, RL do. And AI, ML, RL sometimes are faster, better, and cheaper. So I want to be able to dynamically orchestrate my AI, whether it's an LLM or whether it's AI, ML, RL. I want to feed it just the right context. And then the ontology is actually acting as a control language. It's above the AI, right? I'm using agents to orchestrate the AI using the ontology to send just the right context as a service, to the LM. And when the LM responds, or the AI algorithm responds, we validate that output against the ontology. Because wait, if the LLM comes back and I asked it about cars and it starts talking about oranges, I'm gonna be like, reject this, go back again, right? And so the ontology acts as the not a guardrail, it acts as governance, as imposing strong constraints. Now this is something that people are talking, and then for agents, use the same ontology over the top of the agents, or you can actually say in between the LM and the agent. So put the ontology in between, LM at the bottom, enterprise web in the middle, agents on top. And now instead of having the agents go directly to the LM as an intelligence layer, the agents talk to the ontology. The ontology translates it. It rewrites the prompts. On the fly, it's rewriting the prompt and saying, okay, I heard what you said in natural language. I'm going to translate that natural language into the ontology. And if I have to ask questions back, I'll ask questions back. And then I'm going to rewrite a prompt back to the LLM saying, I need this back. And the ontology now is a control plane between the AI and the LLM serving context as a service. Also, it's this idea that the ontology is now providing persistent, structured knowledge, as well as facts and state and telemetry. Now that becomes almost like shared memory. In the old AI days, you would call that a blackboard, where the agents go, multi-agents can actually all talk to a blackboard, and they don't have to coordinate with each other. They can coordinate through the blackboard, and they can share state. That's this is what everybody in the world wants now. If you read the latest analyst reports on Google's AI agent stack, on IBM's agent stack, on Snowflake's agent stack, on anybody's Databricks, AWS, they're all saying the need today is, they're calling it a harness. They're all accepting that LLMs can't work on their own anymore. That you need this harness, you need this layer that controls them strongly, because you need to be enterprise grade, right? Real time, enterprise grade, contextual automation. So enterprise web sits in between being hyper efficient, communicating between, being able to reason, because we're an ontology, doing reasoning, and provide very precise context both to the LLMs and to the agents to optimize business outcomes and because it's going through the ontology and it's going through models, it's all explainable. What did the agent ask? What was the request? What did the ontology map it to? What did the ontology send to the LLM? What did the LLM send back? Right? It's all logged and traced. What did you give to the agent? Right? Was it filtered by permissions? Right? Well, you know, and I know that banks need that. By regulation, they must have that, right? And there's a lot of industry, healthcare industry, almost all major industries either have regulations or industry standards that require them to be able to have audit trails and logs and traces. So there is secret sauce, of course, to how we can do that so efficiently. And so, and that's
My next question is coming for that. My next question is coming for that.
Okay.
That secret recipe.
Okay.
I am a bank or I am a telco, for example. Let's take two domains. Mm-hmm. Can both customer take your same flavor of enterprise web, or you will customize it for each domain or industry?
Well, so it's both answers. So enterprise web. So the secret sauce itself is we have 23 awarded patents on how to make graph processing efficient. So the way, and just to really summarize that very quickly, because I think some of the very technical people on your call will probably want this, including yourself. And so enterprise. So there's graph databases. Remember, I said no formal logic. And then semantic web has first order logic and description logic. Enterprise web is the next layer beyond. We are higher order logic, functions, and types. So higher order logic supports more complex reasoning and more complex mathematics. So enterprise, and that's the beautiful thing about enterprise web, is that we're computing graph relationships with math, right? Commutativity, adjacency, associativity, right? Whereas in normal graphs, you have what's called the traversal problem. You have to walk the graph. You have to walk the types. You have to walk the class hierarchy to understand what something is. That's a very expensive operation. Every time. So if let's say it's a specific interaction, it involves 5 objects related to a specific infrastructure. Each one of those objects has its own complexity, and then you have to resolve them all together, resolve them in the context of that request, and then deliver that. That's why you have to pre-optimize your queries. In enterprise web, is we can model all the complexity. But when, if you think of it this way, in a graph, in theory, it's called a certain kind of approach is called sparse matrix. In a sparse matrix, every 2 points, no matter how far in relationship they are adjacent. Right? In other words, we don't have this problem with the multi-hops. We don't have the problem with traversals. We use math to say, when Mustafa calls me from Malaysia and he has these permissions, RBAC, ABAC, and he's calling about this object, and we know the state of this object, we know the profile of Mustafa, we know RBAC, ABAC details, we know the history of this object, we know all the related things connected to this object. As soon as you call me, Enterprise Web goes in, we use your request or the event to bootstrap traversal of that graph. But instead of following links, Enterprise Web uses math to flatten that graph to just what's relevant, sub-second speed. We could take thousands of operations and we could actually just reduce it to a boom. We have all the context that fast. And we don't have to hydrate everything about every object. We just have to hydrate what the relevant aspects of the object are for that interaction,
Mm-hmm.
right? Well, you can't do that in the other ones. It's all the object. It's the full object or none. You have to for them, you have to serialize the whole object just to start, right? In enterprise web, we're like, I just want the pieces, the relative. We were talking earlier, and you said, well, you have a role and you have complex multiple roles, right? And all those roles in different aspects of your life. But actually, in this interaction, only one role matters. Why do I have to look up all of Mustafa when I just want to know the parts of Mustafa that are relevant to my interaction? I want to know the context, right? So we're able to flatten that context to just the very precise amount. And what we're doing is it's a flattening, and then what we're able to do mathematically is it's called the lift. We're able to take that lift and take that context and put it into a function, right? So it's like, hey, so if there's a transaction that has to happen, a workflow transformation or something like that, right? We say, here's all the context, perform your transformation, and then add it to the logs, write it back to the trace, write it back to memory, persistence, all those things like that, and do that sub-second. So that is sort of this secret to our approach, and the sort of the subject of our patents is that ability to do that mathematically so hyper efficiently, so that you can actually have real-time enterprise-grade contextual automation. But I'm sorry, I drifted. You were asking, modeling for domains, right?
Domain, yeah.
Yeah. So this is also a very great question. Remember what I said is, modeling in SQL can be tedious. Modeling in a GraphDB, if you're doing it right, it can be tedious and time consuming. It's tedious, it's technical, it's time consuming. It's also error prone, let's be honest. If you don't know exactly what you're doing, you could do it wrong. And if you do things foundationally wrong in a model, you might have to undo some things, right? You have to you go backwards. That's actually a real pain in the butt. So in enterprise web, so I'm going to answer the big question first is, because we do remember I said higher order logic, higher order functions, higher order types, we have a layer above the ontology called a meta model and a type system.
Okay.
And a meta model and a type system is sort of the logic of how enterprise web works, how types work in enterprise web, and how generic information about the universe. Like, we know what organizations are, we know what people are, we know what facilities are, going down quite a bit, right? We know what organizational units are, we know what we know the cloud, right? We know what types are, formats, protocols are, right? We know all these things, so that when we can use that meta model and type system of our language. Remember, we have a language. It's called the Graph Object Action Language, or GOAL, right? GOAL, because we're a goal-oriented language. So Graph Object Action Language, and that GOAL language has, like all languages, exposes primitives, building blocks, and services. Now, to answer your question, instead of trying to build an ontology from scratch, since enterprise web has primitives, building blocks, and services that help you build ontologies. So instead of this being tedious time, and you asked originally about how do people do ontologies, and I explained that there is a conventional way to do it. There is a rigorous process. I mentioned that woman Jessica and her ontology pipeline, and that's all good, and people should look into that. But we're saying that's not for the enterprise. The reality is, that's very hard. Very few people can do it. It really requires an impressive amount of discipline. And what we're saying is, look, just for the same reason people want LLMs, people would like it easier to make ontologies, right? They still want a rigorous ontology, but they'd like it easier. So we have higher order logic, types, and functions that create the primitives, building blocks, and services. And so you can start with enterprise web. You can give us a LPG model. Right? You can give us a model in Cypher, right? Cypher is the standard language, right, for LPG. And that comes from Neo4j, right? So kudos to them. And then you also have semantic web, RDF, which is a standard. So you can give us standard. You can give us SQL. You can give us a Word document. You can give us Excel. You can give us XML. You can give us JSON. You can give us anything, right? Because you know from your corporate enterprise experience that the enterprise models in all those things, right?
Yeah.
Right? And not just one, they model it all. You can give us those. Enterprise Web does what we do. Now, this is sort of like an LLM, but different because we do it against a model, not against
Mm.
probabilities, right? What happens is enterprise web introspect. You upload your sources, super easy, right? Because most people have some models already. We don't have to start from zero. So they import whatever they want, and enterprise web introspects each of the documents or files, right? Or it could even be an endpoint. Point us to an endpoint, and we'll introspect the endpoint, right? And what we do is entity extraction, algorithmic mapping, because we have that higher order, we have that meta model, right? We have a type system. So when we start doing that, we're actually able, I'm talking about sub-second. We're able to introspect your document sub-second. We're doing this with Snowflake now. We've shown how we can take a terabyte of data in a sub-second and map it, right? Like this is, I'm sorry, sub 1 minute. It's a function of the tables. So for a terabyte, and it pretty much stays fairly flat. But for something smaller, we could do it's mostly sub-second. And so we take it could even be pseudo UML in a Word document, right? Like a lot of the standards bodies, they don't give you an explicit model; they give you UML, right? And UML is, we know, right? It's not great. And so we take that, but we can say, okay, we can see the relationships, we can see the entities, we extract that, and then we bring it. Our meta model is we're using the meta model and type system to dynamically type those things on import, right? So we say, oh, you just imported these things. These 100 things are services. These 100 things are applications. These 100 things are resource nodes. What are those? We're rating and scoring them, but very different than an LLM. It's not probability. If we can explicitly map it, it's exact match,
Hmm.
right? That's a big deal. So,
It
like
is
most of the time,
actually
a
you have
very big deal.
you have opened a new Pandora box actually. What you're telling me, see, creating ontology at an organization level is a very tedious job. First of all knowledge, everything sitting into minds. Either it is into documentation, and we all know that documentation is written one time, never gets updated, right? It's always
And the documentation might not even be correct the first time, right?
correct. So now it is always from bottom to up. Now, what you are saying is people, and we are in an era where people already have applications. They have OLTP applications. They have knowledge graphs already sitting there. Neo4j is an example you have given. They have data warehousing sitting there. They have logical model and physical models. ERD diagrams are there. So what game changer for me is you are saying we give them what we have, and one time your patent and whatever you have, you will read everything. Of course, you will have a base, something base for banking. Let's take an example. Base will always be there, and you will be reading. For example, in if you talk about banking, of course, we all know how banking works. It's a very mature industry. We already know. I'm sure you already have it in your web. What do you call it? Enterprise web.
Yes,
And
yes.
then you go and read everything, and then you build this ontology on top of it. Actually, you solve this biggest problem where you are dependent on people to create an ontology and then give it to AI. So you
Yeah.
build that, and I'm sure this is one time only. You do it one time,
Yeah.
and then you
Oh, no,
upgrade.
no, no. It's even better than that. You can actually maintain it this way too, because see the value of our higher order logic is that we also have all of so when we model this, right, and we create that ontology, we create them as immutable objects, immutable typed objects. Right, so they're all defined in software. They're all defined in metadata. Right, they're all mapped. Right, because even if you don't realize it, we're mapping it up to the type system. We're mapping it up. Right, and so these objects have temporal history, right? So we know every change to not only at the entity level, but at the concept level. Because think of this: if you're a bank, banks don't change very fast, but some industries don't change, but they do change, right? And change can cost $20-50 million, take 5 years, right? I mean, it's insane, right? In enterprise web, we literally, let's say one organization, you do a reorganization, and now this division moves over under another
Yes.
group, right? All right. Well, that could cost $10 million, right? In
Yes.
enterprise web, we're like, that's ridiculous. It's just one node being repointed to another node. We'll preserve all the history of that node up to that moment when it was under this node, but then we're going to remap it to the new node. The history remains. We know that it was one time mapped here, but that relationship no longer exists today, but it did exist in the past.
Yes.
And now it maps to this domain, this node. And same thing is you can think of over time, new concepts come in. At some point, digital banking became a concept, right? Microservices, right, became concepts that banks had to understand and manage. And so enterprise web is extensible. It has temporal history. So you're right. We're addressing the fundamental architectural problems of managing complexity and change. Actually, most people don't even pick up on that. So you're very much spot on. But the thing is, we still want ontologists to look at it, review it, and if we can't remember, sometimes you mentioned it too. The inputs that we might get might be imperfect. They might not all be well labeled, or might not be consistently labeled. So we exact match everything we can, right? And when we can't exact match, we drop into probability because we have to, right?
And then give it to people to review it and fix it again.
Then we give it people to, and then they can remap it because it's all loosely coupled, right? Right. So they're all just pointers, right? They're just all pointers based on, and they can be policy-based pointers as well. So, and you can start seeing is we're putting and this just makes sense, right? You model your domain. Right, becomes your domain language, right? And we make it easy for you to model your domain. We make it easy because we have a language above you that provides the higher order architectural framework for managing the domain itself, right? And that's what's been missing across SQL, label property graphs, and semantic web is they have no abstraction, right? There's no rich abstraction layer that supports modeling complexity, managing the use and the change. Security is not native to semantic web. Change management is not native. That means it has to be hard coded separately, right? Enterprise web, it's native to the architecture, right? Because everything's reduced to a primitive, and that's what you really want when you're actually talking about complex things. When you think about no code and when you think about declarative, what you're really talking about is shifting the management of complexity to a runtime that actually handles your complexity. So you could speak at a higher, the reality is all the things that we just discussed for the last hour, you don't need to know them to use enterprise web. You can just say, oh, here's a cool tool. It lets me take all my documents, ingests them, creates an ontology. I can review it. I can start using it the same day. You're talking about, I mean, even with like Palantir, spend $1 million, $5 million, $10 million, $50 million, right? Take 6, 9, 12 months. And that's all tightly coupled, right? That's all and essentially they own it, right? It's here, your people can control and it becomes your asset. And from day one, it supports agentic AI. From day one, it supports LLMs, right? From day one, you could start talking to the business, NLP. Right? From day one, it supports orchestration, automation, configuration, transformation, right? Because in that layer, we're actually orchestrating everything, right? So it's so enterprise web, if you were to look up what we're doing, it's ontology-driven orchestration. It's knowledge-driven automation, right? So enterprise web is sort of crossing a boundary between knowledge engineering and high-level programming, right? So that we can because let's go back to that definition of context. Context is the relevant information to an interaction filtered by permissions, right? So that has to be, to figure that out, it has to be orchestrated, right? these are my data. This is my ontology. These are my data sources. These are my systems. What can Mustafa see? What do I deliver to him? And how do I do that super fast? So enterprise web is knowledge-driven orchestration. So I know we covered a ton today, but I
Nah.
hope that was clear. I hope that was clear, Mustafa. I really, I want your audience to understand, and because I think everybody's looking to try. Everybody's struggling, right? All enterprises are struggling, and they know at this point that AI is not a magical black box. They know that agentic can be dangerous, right? It's been deleting databases, right? It's been deleting database backups. Agents have hacked their own guardrails. So actually, some of the cool things, if you go to our website and read some of our blogs, it's the latest stuff we're doing with Snowflake, obviously one of the biggest data players in the world, and we're doing cool. Now we don't do the data layer, right? So Snowflake provides world-class data analytic and AI services. Enterprise Web provides the knowledge and the orchestration on top. And then because they're the data and we're the knowledge and orchestration, we can now operationalize data in the warehouse. Think how powerful that, because warehouses normally are like become warehouses, right? What do you do with it? Right.
Yeah.
So this is like you were talking. I know you spoke to Bill Inman, and you might be having him back on again. So I really respect his work. More so than I think he's been actually talking to. Bill Inman, I think, did an interview with that woman Jessica as well. So that probably be interesting to you and your colleagues. But Bill always had this idea when I don't know him like you do, but Mr. Inman had this notion of normalization at some level, right? Right, as opposed to star schema and Kimball, right, which was just dimensional semantics, right, which is that's what the data layer just does, dimensional semantics. But dimensional semantics are not knowledge. When people like at the data layer talk about semantic layers, they're just talking about metadata catalogs, metadata trees, things like that, right? But they're not talking about more abstract conceptualizations of the domain, right? That are not. Remember, ontologies provide meaning and shared understanding. Metadata by itself is just tags.
Yes.
Right.
Yes.
So yeah, it helps with queries. It helps with some things, but it doesn't support higher order inferences and reasoning. And so so there is you start realizing it's like Bill Inman, data warehouses, Inman normalization. And we wouldn't use the word normalization. We would actually say we're like a 6 normal form of 5GL, right? A 6 normal form means a fully abstracted data, right? Because we're a sparse matrix that has temporal history. That's what 6 normal form is. And a 5GL means a constraint-based language that's dynamic. And that's that. Clearly that's fairly advanced computer science.
Yeah. So when you say 6 normal form, people will start thinking about data vault actually. So we are not talking about data vault. We are talking about ontologies. Again, just to close, going towards a closing note, right?
Yes.
I'm a customer. What as a product, enterprise, what is your product? Is a SaaS product? It's a IaaS product? What it is?
So enterprise web. So that's a great question. Let's go back. So enterprise web at its core is an integration and automation, a declarative, a no-code integration and automation platform for real-time enterprise-grade contextual automation. There's thousands of no-code products, but as you know, most no-code is for citizen developers, right? It's for simple apps. And as soon as done by business users, and the problem is you're going to get an explosion of these apps, right? That are disconnected, right?
Yeah.
It's the same old problem again and again and again. Everybody does things for convenience, but overall that becomes a big negative for the enterprise because you have an explosion of things that you now have to maintain, and they become a great technical debt for the enterprise. And so with enterprise web, we're different. Our slogan is no code, no compromise. We're a no code declarative platform for you, for the solution architect, for the system engineer, for the data scientist, right? Because we're supporting cross-domain top to bottom, unified views. That's the whole mission of enterprise web. So we're helping resolve some of these big architectural problems. But our platform, believe it or not, I know this is going to sound crazy, our entire platform is only 50 megabytes.
Also, you give this to customer, they
You
install
get to
their own environment.
or in the cloud. So we're
Yeah,
like
yeah.
Amazon. We're Amazon partner. We run on Amazon, GCP, Azure. We're Snowflake partners. We've won awards with Dell, Intel, Red Hat. Right? We can run anywhere in the cloud. We tell our customers deploy us where you want to. If they want to run it in the cloud, they can run it in the cloud. They want to run it on prem. But 50 megabytes, that means we can run on a laptop. That means we can run at the edge. It means we
Yeah.
can run. 50 megabytes is iTunes is 450 megabytes.
Yeah. So you're this
50,
product. So you're this
our
product.
50 megabytes can run on your phone,
So,
right? It's that powerful.
yeah. So how to buy it? Is it a one-time license? Is the subscription? How it goes?
So it depends. If you want to put it on prem, it's a subscription license.
Okay.
If you want to put we're now working with Snowflake and we're about to roll out a consumption licenses.
Okay.
Sort of modeling ourselves, aligning ourselves with like cloud-based models and SaaS-based models, but consumption, and so that just scales out. You can easy, low barrier to entry. Use it as much as you want, because we know when people start, they're going to just scale it out, because that's what we're meant to be, is scale out. So it's 50 megabytes, cloud native and serverless. So our enterprise web is, remember, we're fully dynamic. That means everything happens in real time.
Mhm.
So we ourselves are stateless. We manage data we manage state in a cloud native asynchronous, concurrent, massively parallel way, which makes us very hyper efficient, right? But let's answer the easy question, because I appreciate that you asked it. Subscription models, honestly, we are super reasonable compared to anything like Palantir, Pegasystems, because we want customers to take it and use it as much as possible. We want to make money based on their success, not trying to squeeze money out of them, right? We want to create new efficiencies for them. We want to, honestly, I want to be transformative. I want to be transformative at the technical level to enable new business outcomes. I also want to be able to be transformative at the business level, because I fundamentally believe that these capabilities should be global. Everybody should have these capabilities. We need to lower the cost of context so we can optimize our transactions. So 50 megabytes subscription or consumption license, if it's in the cloud, it can deploy, and you can do both. You can do hybrid. You can run partly in Snowflake or Amazon and then partially on-prem, right? And then enterprise web will synchronize just like another node. And deploys in minutes. We can actually have a use case up in a day or two. This is a starting use case. We can then, the way you can start importing your things, you can actually start growing your domain iteratively over time. You can say, okay, you don't have to do it in one big bang. Here's the documents, prove this use case with this complexity. Now grow the ontology, add more documents, add more files. Now we've grown the ontology, we validated. Now we can support these additional domains. Let's extend the abstraction, and you can grow as you go. So instead of having like a team of 10 forward deployed engineers that you need for the rest of your life deployed, we want to just train the customer, let them do it. We can also work with their SIs, their system integrators, but it's easy enough if they have the teams in place. We can train them to do this, and they can manage and own it. We don't really want to own the services side. We just want to be able to sell licenses at a reasonable price that they can scale and they can run. We think that most enterprises want to get away from heavy solution engineering. It's too time consuming. It's too expensive. It's too brittle. That they actually want to create an architecture, right? That actually helps them do these things. And this has been holy grail stuff for a long time. Everybody's always wanted it, but they've always hard-coded the things. And now we're giving them a way to do it in a loosely coupled manner that models their complexity, supports their agility and change, enables them to put a harness over AI. And I think I think we're finally in the right place at the right time. Like I said, like I think offline when we were talking, I said when I was talking about these things like around 2010, 11, 12. I mean, at 2011, I spoke at the worldwide the W3C conference in India in Hyderabad, and Sir Tim Berners-Lee was there. I sat next to him at lunch, and I was expressing these ideas, and nobody knew what I was talking about, even in the graph community. I presented at IBM. TJ Watson, the worldwide research center for IBM, spoke to hundreds of PhDs at IBM, right? And they were like, how do you do that, right? So it's taken a long time for the world to understand the need, but I think now everybody's really looking and saying, I want a horizontal architecture. I need to rationalize my solutions. I need to eliminate tool sprawl. I want unified views. I want centralized policy control. I want end-to-end automation, and we can provide it, and we want
I
to
can
do
I
it.
can I can already think about few use cases actually. The obvious use case I can think of, there are many surveys which says in big organizations 70 to 75 projects are on shelf. People nowadays don't call failure, they put it on a shelf, they just show the board that hey, product is working, right? So your this enterprise web can expose those products, their usability, whether they are in use or not, someone is using or not, whether it is required, and they can easily decom that, right?
Yes.
This saves so much of money. Second use case I can actually see this implementation on my DAS architecture as well. I was telling you offline that I wrote a monograph for Bill and Mon, right? So I'll share those links with. So in my DAS architecture, there's enterprise zones and there is business zones. Like the data mesh, I can say in data mesh, you can use this because there are so many domains talking to each other. Nobody knows what is happening. So this can give a
So if I could, that's a great parallel. Data mesh was a good idea, and I'm sure you both know the author of that, right? It goes back to ThoughtWorks, and like 10. But most data mesh projects fail,
yes,
right?
because
Well, just like
so many interconnected and people are so confused.
because they have no, and I actually talked to the original author of it. I actually had an exchange with her by email at one point,
I tried to
like
connect
five,
with
6 years
her.
ago.
She don't want to talk to me. Never mind.
Well, because I honestly I found it frustrating because I think sometimes people in the technology world can be dogmatic. They only want to talk about their thing like it's this pure, like
Yeah.
it came from God or something like that. It's just technology, right?
You have to
It's
improve
just
it.
like yeah,
Improving
yeah,
is not bad, actually. People think if you improve your stuff, it's against them. It's not.
he was against abstraction, right? And I tried to say, no, your data products are never going to work in production because you can't just have a thin entity layer, right? You
Yeah.
can't just have very shallow, because you need shared meaning over the top. If you don't have shared meaning over the top, these data products are going to be, how are you going to find them? How are you going to discover them? How are you going to compose them? How are you going to use them? How are you going to manage them? So, I mean, there's the same problem on the IT side on microservices. Okay, great. You decomposed. You've got lots of microservices. How do you find them? How do you manage them? How do you govern them? Right? And like the people keep on hitting the same problem again and again. You need common abstractions to manage that. And look, I do understand that historically, building a common abstraction has been hard, right?
Hmm.
That's what we made easy, right? That's what it boils down to is we've made the abstraction layer easy. It exposes primitives, building blocks, and services to the data side, to the application side, to make their jobs easier. It doesn't do MDM. It's not forcing. It's a service. The
So
ontology ends up being a service to the
yeah,
enterprise.
yeah. So we can say it's a part of a governance. I can visually see that governance is always horizontal. Yes, at
Yep.
a LOB level, at a product level, they have their own, everyone has their own governance, but there has to be a centralized governance, which is we can call it a horizontal, right? And I think your
Yep.
product can very well sit over there.
Yep. Yep. And and in the AI world, if you look at what all the AI analysts are saying, they call that the harness. There's no solution for it yet. They're just calling it the harness. And the harness is sort of a mix of governance and back end,
Hmm. Hmm.
right? And that's what enterprise web is. Because as soon as you start creating that global unified layer, you'd actually have to like to have some unified tooling too, right? Even
Yeah.
for data mesh. Even for data mesh, you'd like to have unified integration, orchestration, configuration, transformation, right? Because you don't want to have every damn team doing that separately on separate sets of tools. Right? It doesn't make any sense.
They
So
want
it doesn't mean
autonomy,
that.
but they want autonomy, but they forget about centralization management.
Yeah, and the cost of it, and the trick is you need to make it easy for them. If you make it an easy service for them, as not an imposition, but say, hey, here's your data, and here's how it's represented up here, and look how easy everybody can find it, and here's some tools that you could use. If you want to, you can use these tools. They'll make your job easier rather than doing it down here and compiling it for us up here. And by the way, you'll save some departmental budget.
Yeah.
Right now, all of a sudden, it starts looking good. If you start from the position of like, hey, here's the central enterprise control layer, we're pushing it down on everybody.
Mhm.
Everybody rejects it. For 20, 30 years, right? Everybody knows that you might as well shoot yourself. You're not going to win. You have to come in and provide it as a service and show how you make each team and division, line of business life better individually and collectively.
Hmm.
Oh, look how easy it is now to interoperate with other teams, because pretty much every division to do anything has to talk to other teams, and now instead of doing swivel chair, right, and point-to-point integration, now they can do it through the abstraction layer. Oh, I take my information, I pump it up here, it gets into a pipe, and it can be shared down below. And now you get those higher level enterprise processes like order to cash and other things like that, right? That can just run right across. Why should I do them right point to point?
Awesome. I think this is one of the longest podcasts I had, but and I didn't feel it that it went more than 1.5 hours. I hope our audience
Sorry.
will like it. I think we have covered a lot of pieces and we really went toward started from strategic up to the level of how it can be implemented up to the level of 50 MB, right? That you can
Yeah,
install
yeah,
in your mobile, right?
yeah,
Yeah.
yeah. And we talked about data. We talked about functions. We talked about orchestration. Like think about all the different. We talked about graph. We talked about C. We talked about. But that's the way of the world today. Is we need unified theories, right? Is like the reality is the people who are going to succeed in the future are going to be able to think across data and process. Not just be a data guy. Don't just be a graph guy. Don't just be a process guy. Right? Don't just be a governance guy. You have to understand these things all interrelate, right? And
Absolutely.
you have to understand how they interrelate. To think of them in isolation is silly. And so, no, this has been a true pleasure. And I'm sorry, I am a bit famous for being a talker. But the thing is, you were asking very good questions. You were winding me up, and I think this will be a great asset, hopefully for others. And of course, I know you do. I welcome feedback from anybody, so people can find me on LinkedIn. I'm just Dave Duggal, and you can put, I'll give you my links and stuff,
Yeah,
and
you can.
they can find.
Yeah.
Yeah, I blog on Medium. I have videos on YouTube, so you can find more information about us. But thanks. It was a true pleasure, actually. We'd never met before, so this was our first interaction, and I really enjoyed
Yeah.
it.
And let's be in contact. I definitely learn a lot from you. And let's share
Okay.
experiences. And I love products like you. And one of the advantage I get out of my podcast is learning products like this, which is not exposed to the whole world, right? Because we all know that the product which are exposed is either Oracle, IBM, Microsoft. You can name it on your fingertips. Those are the products across the globe. But
Yeah.
very niche product like your, it's not
Yes.
everywhere. So I feel that my podcast, the audience are around from 35 countries. I think that's the value add I bring for my guest as well, that my voice, wherever it can go, can take your product over there. I hope people can contact you. Definitely, I'm going to contact you. I'm running my
Great.
own little bit entity with someone in Malaysia. So let's see how we can work. And I am in contact with a lot of people over here. I'll be talking
Okay.
about your product because I love it. Because
Okay.
I don't have to be dependent on people knowledge in their mind, and I don't have to ask them to draw something. You can read my SharePoint, all my documentation, you can read my logical models, and you can build something out of it which can be reusable horizontally across the organization. That's a takeaway for me.
Yeah, yeah, absolutely. And I have to apologize. It's your Friday night in
No,
Malaysia,
no, no.
and I know you were going to go out with your family for chicken satay or something. And
Yes,
so I want you to go. Please apologize to your family. I'm so
they're
sorry.
listening.
Uh, and so they've been very patient. You have a great weekend. Thank you so
You too.
much, and I look forward to being back in contact.
Pleasure, pleasure. Have a nice weekend. Take care. Bye bye.
All right, ciao. Bye bye.
Bye bye.